Alright guys, so today we're doing work energy question papers or questions. So yeah, you're more than welcome to pause the video and attempt the problems. Alright, now let's begin. So the question statement reads as follows. A load of mass 75 kilograms is initially at rest on the ground. Now it is then pulled vertically upwards at a constant acceleration of 0.65 meters per second by means of a light inextensible rope. Now refer to the diagram below, ignore air resistance, rotational effect, and the mass of the rope, right? Okay, now what is happening here? So we're told that something's been pulled right vertically upwards. Okay, this is good. Okay, and at a constant acceleration of 0.65. And okay, so that is what we are told, and that thing that is being pulled up, its mass is 75 kilograms. Okay, right now, since we have seen what is happening and we have tried to debunk it, I think it's time that we attack the question, right? So 5.1, it reads, draw a labeled free body diagram to or for the load while it moves upwards, right? So there's only two forces that are going to be acting, which is the Fg and the tension, right? Only two forces, right? Fg and the tension. Now for 5.2, name the non-conservative force acting on the load. Now, what is a non-conservative force? As I said in the introduction of this course, I said a non-conservative force is the type of force that is dependent on the path taken by the object. Now, is Fg dependent on that path? No, it's always there. But tension, it is dependent on the path. So basically, we can say tension, because without the rope, tension doesn't exist. So it's tension. Now, for 5.3, calculate the work done on the load by the gravitational force when the load has reached a height of 12. Okay, so they want us to calculate the work done on the rope by the gravitational force. So the work done, we know that it's going to be F changing X cos theta, right? So we're looking for what? For the weight. It's for the weight, alright? So this is the Fg. Now for the force, I know it's defined as what? Mg changing X cos theta. And then now the mass, it's going to be 75, 9.8, and the change in X, which is going to be what? It's going to be 12. And then the cos, what? 180. Now, here's the reason why. Fg, we take it as a force which prevents motion in this case. You're trying to pull something up, but there's something that's pulling it down. That's why we say it's 180. Now, for someone who doesn't understand these references of 180 degrees and 0 degrees, please do this. Take this dot as the origin, right? Now, up is the motion that we want. Now, if we want to go up, what will be preventing it? Fg, right? So Fg, it's the what? It's the frictional force in some sort of sense. So that's why they say 180, because 180 is gonna produce what? It's equivalent to -1. So it's an oppositive. It's something that is opposing the motion of this bucket or whatever this load of mass it is. So you're more than welcome to take it in that analogy to make your life easy. It's more of like Newton's, but the problem is right now the direction has its own placement on the problem. Unlike in Newton's, whereby you can see, okay, Fk, it's the opposite way around, right? Good. Now, let's see. Okay, let's find the answer, and the answer is going to be negative 8,820. Not Newton, sorry, joules. So this is the work done by the Fg on this load of mass, right? Now 5.4. State the work energy theorem in words. Now the work energy theorem in words, as I always say, I do not write definitions, but I only state them. It states that it's the total work done on the object, which is equal to the change in kinetic energy of the object, right? That's how you can define it. Or the net work on an object is equal to the change in kinetic energy only, right? Good. Now 5.5. Use the work energy theorem to calculate the speed of the load when it is at a height of 12 meters, right? Okay, so they want us to use the work energy theorem. As I said before, the examiner is romantic. Whatever he or she asks you, you are gonna use it. Yeah, in the next question. So we want you to use the network, which is equal to the change in EK. Okay. When it is at the 12 meters. Okay. So what are the forces? We know that it's tension and what? It's tension and what? And Fg. Sorry about that. Alright, so from there on we can say on the network side we can conclude by saying or by using the following formula, right? We can use this one and say or F net change in x cos theta is equals to 1 over 2 mass, which is Vf minus V initial squared, right? Yeah. Now, what is the mass of this thing? It's 75, right? So we found the work done by what? By the Fg, right? So we're gonna try to find the tension in this instance. So we're gonna say on the F net, we're gonna say 75 multiplied by 0.65 multiplied by 12. Now the 12 is the distance, and the 0.65 is the acceleration, right? Constant acceleration, right? Remember that a force is defined by ma. Now the mass is 75 and the acceleration is 0.65. So basically this is what? This is tension, right? So this is what we're looking for in the work net, right? Now for someone who's asking why don't I use Fg in this case, Fg it's a conservative force and it's not always the case in most cases, right? From there on we can say cos 0, since it's the one that we're looking for, the one up, and say 1 over 2 75, and the velocity is Vf, the one that we're looking for, and 0, right? Don't forget about the 0. Now you can simplify this. Let me write this. This is 75. Now you can simplify this and get what? Vf to be what? To be 3.95 meters per second. Yeah, this is how you can do it. Now for some, they may choose to take the long route, which is by saying F net is equals to ma and T minus mg, which is ma, and from there on you calculate and you find what? You find this. Now the tension that you're going to get, it's supposed to be what? 7.83.75. Remember that this is 75 times 9.8, and then 75 times what? 0.65. Then the tension is supposed to give you this, right? And from there on you find the work done by the tension. It's supposed to be 7405, right? You just multiply this by the distance of 12, and after you find this, you're going to subtract this from this one. So it's going to be 9405 minus 8820, which is equals to 1 over 2 v final squared, v initial squared, and your Vf is going to be what? The same as 3.95. Same answer, just the long method, right? Right, so just like that, guys, we've reached the end of this video, and I hope that you enjoyed this one. And if you have any inquiries, please leave them below. Just like that, see you in the next one.